So, now we have to discuss work. What is work? You know, work is said to be done when the applied force displaces the body through a distance. Suppose you have taken, this is the surface here, and any body is placed over here and force is acting to this side. Now, the body is displaced to this side. Suppose body reaches to this point here by a distance, by covering a distance s, that is a displacement. Then work is defined as F dot S. F is the force, S is the displacement. So, we can write F cos theta, F s cos theta, that is the dot product of the two vectors. Dot product of two vector is a scalar quantity. So, work is a scalar quantity. Now, you can see here again, if you take the component of the force along the displacement, that is coming F cos theta, and here we can write F cos theta into S. It means work is defined as the product of the component of the force along the displacement and the magnitude of the displacement. So, here work depends on force, displacement and cos theta. If you are taking, suppose theta is equal to 0, you know cos 0 is 1. So, work done is equal to F into S. This is called maximum work done. So, when applied force displaces the body in the direction, applied force displaces the body and the angle between displacement and force is 0 degree, then the work done is maximum. Now, if you are taking, suppose theta is equal to 90 degree, cos 90 is 0, then the work done will be here 0, because cos 90 is 0. So, if the angle between force and displacement is 90 degree, then the work done by the force is 0. Now, we can take another example. If you are taking theta is equal to 180 degree, theta 180 means cos 180 is minus 1. So, we can write work is equal to minus Fs. Here the work done by the force is negative. Let us take examples of all this, the positive work done, negative work done and the 0 work done. Now, see example of the positive work done. Suppose here in positive work done, body is here and it is falling down. Gravity is acting downside, that gravitational force is equal to m into g. Now, when the body is falling down, gravitational force is acting downward and height is also here downward. So, the work done by gravity is positive here, because theta equal to 0, gravitational force and displacement both are in the same direction. Another example, suppose the gas is allowed to expand in a piston, in a cylinder. Suppose you have taken a cylinder like this and there is a piston and here is the gas. Gas is allowed to expand. When the gas expands, the piston is coming to here, its volume is changing, volume is increasing. The work done by the gas is positive. Similarly, you can take the example like the example of the spring. Suppose a spring is stretched to the certain length, then the work done by the stretching force or the work done by the external force is positive. Now, we will take the example of the negative work done. Suppose body is being lifted upside, height is h and gravitational force is acting downside mg, then the work done by the gravitational force or the gravity of the earth is negative, because the displacement is upside and gravity is acting downside. So, this work done is negative. Similarly, if any object is moving to this side on the rough surface, then the frictional force is acting to this side. So, the work done by the frictional force is negative. Similarly, we can take the example of the 0 work done. In case of the 0 work done, suppose you have taken any object, suppose earth is at here and the moon is revolving around the earth. In that case, gravitational force is acting to this side, body has velocity to this side. So, this angle is 90 degree. So, work done by the gravitational force of earth is 0, because the angle between the force and displacement is 0. Similarly, if the coolie is putting some load on his head and walking, then the work done by the coolie is 0. If you are holding suppose a briefcase in your hand and walking, then the work done by you is the 0. So, these are the examples of the positive work done, negative work done and the 0 work done. Now, we can take units of work. So, units of work, we know work is equal to force into displacement. If you are measuring work is in Newton, so 1 Newton into 1 meter, that is 1 Newton meter, this is the SI unit and this is SI unit, which is equal to actually 1 joule. So, SI unit of the work is joule. So, 1 Newton into meter is equal to 1 joule. Similarly, we can take CGS. If you are taking the work is equal to, in place of force you are taking dyne into 1 centimeter. In that case, we can write here 1 erg. So, this is the CGS unit of work. 1 joule is equal to 10 raised to power 7 erg. So, this is about the CGS and SI unit of the work.